Question number 66. Correct order of electron affinity of elements fluorine, oxygen, nitrogen and beryllium. If I talk about nitrogen, it has half-filled configuration. We know that half-filled orbitals are more stable than partially filled orbitals. Similarly, if I talk about beryllium, the configuration is 1s2, 2s2. Paired electrons are present there. It means these are those elements which have very less electron affinity. While if we talk about fluorine and oxygen, they have high electron affinity. Fluorine has maximum electron affinity. Then there would be the turn for oxygen. After that, there is the turn for nitrogen with half-filled electronic configuration, and then here is beryllium. Where this is correctly given? This is correctly given here in option 1. That's why I'll choose option 1 as the correct option. I hope this question is clear to you. Now let's take next question. Question number 67. Which of the following molecules has maximum dipole moment? We have different species given here. If I talk about CH4, CH4 has tetrahedral structure this way, and this is the molecule of this type. And we know that dipole moment is a vector quantity. It depends on direction also. So in this case, the mu value becomes 0, because in this case the bond dipole moment is cancelled out. Mu value is 0. Further, if I talk about XeF4, this is this type of structure, and in this case the direction of the dipole moment in this way, and this results in mu value that is equal to 0. Further, if I talk about NH3, this is the pyramidal molecule. In this way, there's a lone pair of electron. Its direction of the, we can represent the dipole in this way, and this would have a positive value of dipole. Further, if I talk about PCl3F2, the fourth one, the structure is this, in this way. And as I have already told you, dipole moment is a vector quantity. So in this case, the bond dipole is in this direction, here is in this direction, and this way. It means ultimately mu value becomes 0. So there is the single case in which the mu value is positive. That is the case of ammonia, and you should choose that as the correct option. Question number 68. In which of the following species central atom is not sp3 hybridized? So in this case, if we talk about hybridization, in that case, the electron present in the valence shell as well as the lone pairs participate in hybridization process. And if I talk about the hybridization of the species given here, in case of BOH whole 4 negative, for this ion the hybridization is sp3, tetrahedral shape it exhibits. For the H2O, sp3 bent molecule, a tetrahedral structure it is. XeO4, if I talk about this XeO4, this is also exhibiting sp3 hybridization. While if I talk about XeF2, in this case the hybridization is sp3d due to the presence of the lone pairs in the orbitals sp3d. So in this particular case only the hybridization is not sp3, and that's why option 4 is the correct option. Question number 69. Bond order 2.5 is not observed in. We have different species given here. O2 positive. In this case, the bond order is 2.5 because we know that bond order is half of the bonding electron minus anti-bonding electron. Further, in case of NO, the bond order is also 2.5. But if I talk about C2, bond order is 2 only. Now, if I talk about N2 positive, there is also the bond order that is 2.5. So, only one species there, that is C2, in which bond order is not 2.5, it is 2, and that's why the correct answer becomes option 3. Question number 70. Density of air, that's in gram per liter at 307 degrees Celsius and 2 atmospheric pressure is. We need to just find out the density of air. Average molar mass of the air is 29 gram per mole. What is the relation between the density and the molar mass and temperature and pressure? That is Pm by RT, that we derive from ideal gas equation. PV is nRT. So on the basis of this we have derived this relation. D is Pm by RT. Let's place the values here. Density we need to find out. Pressure is given here, that's 2 atmosphere. Now, molar mass of air is given, that is 29 gram per mole, divided by the R value. This R value becomes 0.0821 liter atmosphere per Kelvin per mole, and then multiply temperature also. Temperature is 307 degrees Celsius. So what would become T? That is 307 plus 273. So it would becomes 580 Kelvin. Just multiply 580 here, and this would be equal to 58 upon 580 into 0.0821. Very simple calculation it is. This is 10. So the value becomes 1 upon 0.821. Where this value is given, this is density, and this value is correctly given here in option 2. So the correct answer is option 2. After that,